Hi, Leah, how are you?
Hello, I'm fine.
Good. So, Leo, tell me, what is your problem?
So with in my computer science class for paper two, I'm doing OOP for option D, and I'm doing HL. So in that part, I'm just struggling with the three things I mentioned, which is linked list, queues, and stacks.
Okay. And okay, so you are taking it in Java, right?
Yes, in Java.
Okay, good. And you are able to write classes like you told me, right?
Yes, yes.
Okay. So let me share with you. So I assume that you did hear about linked list, right?
Yes, I have.
Okay. Let me see. So I believe um, that you so do you basically know what is the difference between a dynamic data structure and a static data structure?
Uh, I do know, but I think I still have a bit of confusion about it. So if we could just go reviewing that a little bit as well, that might also help.
Okay, so let me see here. So a dynamic data structure actually it is something that a place in the memory that we are able to store uh, data or information.
Yes,
Let's say it's data, and this is dynamically allocated. It means that we are able to increase the amount of memory based on the amount of data that we have. So if
yes,
you have, for example, if you have a stack or a plate or a, let's say plates, you have 10 plates, and then you want a place to store these 10 plates in just as like, let's talk about physical place first. So if you have,
yes,
you want to store 10 plates in a place, so you allocate a place for that. Um,
yes,
this is, let's consider this is a dynamic way. Um, if we're talking about a static way, it means that typically you allocate um, array of a fixed size. It means that if you happen to have additional 2 or 3 plates that you want to store, then your static place that you fixed cannot be actually used anymore. So that is basically or just on the basic side or the core idea between dynamic um, dynamic allocation and a static allocation. So a dynamic data structure are able to accommodate any increase or deletion of data during the running of a program. But a static
yes, yes,
one does not really cater for that, and it also somehow so you always have to allocate more space on a static data structure than you might need, just in case later you might need to add more data. But with a dynamic one, you don't really need to care about that. If you want to, at any time, you would like to add more space for data, so that is available for you. So
yes.
this is how to say, this is in short that the difference between dynamic and static data structure. So of
I
course
see.
this come with a price, because dynamic data structure is slightly complicated. It's not just an array that you need to add or to even program and or even reserve once you start to run your program, and that's it. No, you really need to take care of many things, meaning not only the size of the arrays that you need to really take care of. when you want to loop through a dynamic data structure, it's slightly complicated. If you want to insert or delete or even add, there is a lot of parameters that you need to care for. That's why it's slightly complicated than the usual static data structures. Okay, does this make sense so far?
Yeah, it does.
Okay, good. So let me see here. Okay, I think you have seen something like that before.
Yeah, I have.
Good. Okay. So may I know from you, just to make the things more interactive, do you know the difference between the head and the tail? Leo, you still hearing me?
No, not exactly.
So but you hear me, but you don't know the difference.
Yeah.
Okay. So link it up. Okay. First of all, so good. So somehow I already know what I need to explain here. Do you know what this portion of a linked list called?
It would be a container.
Node. We call it a node.
Oh,
So okay. Each node contain two parts. Do you know the two parts? Leo, can you still hear me?
yes, I can.
Okay, so Leo, okay, if you don't mind, let me just explain to you, because typically when we have a student, normally we have an introduction class that I explain why I always need to ask questions. So I'm not asking questions to actually challenge you or even test your knowledge. No, that is far away from my target. My target from asking question is actually to how to say to trigger your mind and make it think. If I always give the information for you and you are on a passive state, so the chance that you only maybe grab 50 or 60% of what I say. But when I try to challenge your mind, not you as a person, but your mind, and give you questions, so you put an effort and try to think. So when you try to think, that improve your whole understanding about the thing. So even if you don't know an
Yes.
answer, but you still, your brain try to put an effort to answer. I don't care if the answer is correct or wrong, because we will correct you at the end. The thing here is that if I pressure you as much, you will try to give me an answer. So when you give me an answer, it means that your brain start to organize the information somehow. This is just basically how neuroscience work. So
Yes.
so you will benefit at the end. This is
Okay.
in summary.
Yes.
Okay, so
Yes.
don't take this as I'm just challenging you or testing you. No, this is not the purpose here. I'm not your examiner. I'm just here to push you forward. Okay,
Yes.
so okay, good. So what I want to say in short, okay, node consists of two things. Can you recall what is these two things?
Well, the first part would be the data itself, right?
Exactly, correct.
Yeah.
Perfect.
And then the second part would like point towards the next node.
Yes, so it is a pointer. So we have a place to store data, and we have a pointer, and the pointer is to the next node. Am I right?
Yes.
Perfect, perfect. So, okay, every node have an address. Can you recognize where's the address in the place that we are seeing here? So every node of those, it have an address. Can you see where is the address? Are you able to point
The
out where is the address?
yeah, the number at the top left.
Exactly, exactly. That's good. Okay. So this is basically the address. And when we are pointing, our pointer here point to the address. Am I right?
Yes.
Okay, good. So do you know that the linked list are able to carry different types of information, right? We are able to
Yes.
put strings, numbers, or even classes.
Yes.
Good. So we mark the start of the linked list with something called head. And we mark the end of the linked list with something called tail. Okay, and typically it is pointing to null. So are you aware that we have 3 types of linked lists?
No, I wasn't aware of that.
Okay, good. So, okay, so what we are seeing at the moment in front of us is actually a singly linked list, a singly linked list. So it start with a head, end up with a tail, and our pointers is only pointing in one direction. So we start from here and we reach the end, and then that's it. There is nothing more
Yeah.
than that. Okay, good. So another illustration for how the singly linked list looks like, it looks like this. Okay, so this is just it will make it easier for us when we explain later about the doubly linked list and the circular linked list. So as I said, this is exactly same like the previous illustration or diagram. We have here the head, and this is marking the start of the linked list. And at the end, we have the tail, and it's always pointing to null. Is that clear to you?
Yes.
Perfect. So let me share with you. So this is 2 different illustration of how the double linked list looks like. So you should be able to recognize a singly linked list and a double linked list by illustration like that. So here we have the head, and we have two extra portions here. So previously we only have one pointer, but
Yes.
now in a double linked list we have 2 pointers, one called previous and one called next. So this is previous and this is called next. So this is the place for the data. And this is the same like before. So what we have additional here is the previous portion. Can you tell me your how to say, your comments or your observation about what you're seeing here?
Well, from what I'm seeing here, after it reaches null, it like goes the other way, like using the previous pointer instead.
Yes, this is excellent. So it means that somehow we are pointing forward, and then we also go backward. So it means that every one of every node in the linked list can able to not only go in one direction, so it is able to go forward and backward. Does this make sense to you so far?
Yes.
Okay, perfect. So at the end, when we reach the head or the first node, we point again to so the previous. So for the first node here, the previous become null.
Yes.
Same like the next one here at the end. At the end, it means that the tail here is also pointing to null. Does this make sense so far?
Yes.
Okay, good. So let me ask you first one thing before we move to the circular linked list. Where do you write your Java code?
My Java code, well, if I'm compiling it, I write it in Eclipse. But if I'm like But if I'm like practicing for like the test, then I just write it on paper.
Okay, perfect. You are using a computer at the moment?
Oh, right. Yeah. Right now I'm using a computer.
Perfect. So I would say the circular linked list looks like this. So it means that, okay, this is the head. It is much more closer to a singly linked list, except one thing, that the tail here points to the head. So
Yes.
we also have data portion. We have a pointer. And except that it is all the same, it's always moving forward, except that the tail is again pointing to the head. Does this make sense so far?
Yes.
Okay, good. So, okay. So in the exam, you need to be aware of writing diagrams like this that can show an insertion of a node in the middle. So initially, the linked list was one node, second node, third node, and fourth node. This is what we saw previously. But then
Yes.
we decided that we want to add a new node here that contains all. So we want to think now how we are able to insert that node in the middle. So if you, I'm not sure if you ever studied different insertion or ordering algorithms in Java, but if we are trying to, yeah,
No, I don't think I have.
okay. So typically, if you want to order a list or even insert um, in something in the middle, that actually can take a lot of effort and operations, and also it's not so straightforward. Okay, sometimes we need to use two lists and then copy from one part to another. But anyhow, let us have a look here. So because we are always depending on pointers, if you can see here, so this have a data portion and this have a pointer portion, right?
Yes.
So I would like you to have a look. Last time, this is supposed to pointing to not 920, but supposed to be pointing to 645. If we have a look here, if you can recall, so these two nodes was connected together, right? So in
Yes.
this node, our next portion or our pointer was pointing to 645 here, right? But if we
Yes.
want to insert something in the middle, so we have to really break that connection. That connection is based on what, in your opinion?
Uh, hmm. Well, the connection would,
Don't be afraid. Even if you
yeah,
say wrong, there is nothing wrong.
yeah,
I mean, there's not an exam here.
yeah. So I forgot the exact terminology, but it would be like the number on the pointer and like the, how do I say it? Like the, is it called like the address of the next one? I'm not sure how to
Yes,
refer to
yes,
it.
yes,
Yeah.
exactly. You are saying it correct. So it's a pointer that is pointing to the next address, next node address. So yes,
Yes.
so if we want to break that connection, so we have to really play or change on the pointer portion, pointer address that we have here. So instead of 645, then we have to come to modify that portion. So if we look here again, that portion, this is the part that we was talking about just now. So as I said previously, this portion was having 645, and we removed that, and then we insert something different. So this is the new node, and what we are trying to do is that since we are going to link this node at this address to that node with this address, so it means that to establish the link here, our next pointer here need to point to that new node address. So we have to get this address, we have to insert it here. Does this make sense so far, or?
Yes, it does.
Good. And so, and here, since this new node, suppose it was not pointing to anything, because suppose this is totally empty, but since we want to link it to the last node, which is this one, so we grab the address of the last node, and then we insert it here on this new node that typically comes with no addresses here. So now the pointer of this new node will be pointing to the tail node or the last node. And typically this is remain the same because this is a tail. So it's pointing to null. So far, does this make sense to you?
Yes.
Good, good. So this is exactly another way of illustrating what we did previously, except that sometimes in the exam, they are asking you to actually write in steps what you need to do. So if this is a new node that you want to insert, and then I would say the steps to insert a new node is to, okay, create the new node with the intended value. This is the intended value, okay? Adjust the pointer of the existing nodes so it become part of the chain. So this is the kind of steps that if you are required to explain how to insert a new node, so you need to write something like that in the exam. So
Yes.
typically, they accept either you explain this in this way, or you even illustrate using a diagram. I see answers that is approved, and you are giving the full mark if you just write a diagram like that. Okay?
Yeah.
Okay, good. So did you see the requirements of for your exam? I mean, specifically for the linked list.
The requirements, no, I don't think so.
So basically what you need to know about the linked list, it is maybe not fully, but this is what you need to do. So you should be able to describe the features and characteristic of a dynamic data structure. This is something similar to the comparison that we have seen just now. So you should describe how linked lists operate logically. Okay, so you should be able to sketch linked list single, double, and circular. Sketch. So I think we have seen a sketch just now, right?
Yes.
So this is what you need to be able to do in the exam. Let me see what else. Yeah. Other than that, comes the portion of the code. I still need to share with you something about how you delete a node, okay? And also it's somehow similar to the adding and inserting a new node. So, but bear with me. I would like you to, if you have your computer now, you're able to share your code. So one way is that we work on an online compiler, which I typically use for all the classes, or you're able to use your Eclipse if it is handy at the moment. Okay.
Yes.
So, and typically every 30 minutes we close and we open again, and at the end, of course, you get a recorded session for everything. Okay.
Yep.
Good. So let's continue. Let me see here. So one way that we are able to actually explain how this linked list is there in the memory. Let me try, please, to is that clear to you?
Yes.
Okay, so I mean visually clear. I don't need I didn't ask you to fully understand yet. So typically this is the addresses in the memory, or we assume the RAM. You have studied computer science, right? So you studied how the memory is organized internally, or not yet?
The audio cut out for a bit. Could you repeat it? Sorry.
Okay, no problem. So what I was asking you, do you know how the memory or the RAM stores the information? Have you studied that yet?
Yeah, I think I have.
Good. So every the portion in the memory, the information is stored actually in the sequential manner. So there is every place in the memory or even in the RAM is actually addressed. It have an address. Same like houses. So if you want to reach a house, you need a number of a house. Am I right? We have Laurent, we have a Taman, and then we have a house number. Am I right?
Yes.
Good. So this is the address where information in the memory is stored. So let me see. Typically, in an address like that, they have to write information that is called head equal 101. So this is how a linked list can be really stored in the memory. So it is not stored in using the diagrams that we have seen so far. It is stored in a sequential manner like that. But what actually mark our starting address is something like a variable that can tell what is the starting memory address for our linked list. So a linked list start at 101. So you find the data portion here. So these two form a node. This is the data portion of the node, and this is the next pointer. So if you can recall previously, we have them something like that. So we have to close and we have to open again. This is already 30 minutes. Okay?
Yep. Yes.